All right, let's start off here on number 1. So for this one, we want to find the indicated side x, and they're telling me I have this is 17 and this is 22. So it looks like we have no complete fraction here for our law of sines. It is the side angle side, and so I'm going to use law of cosines. Also, it kind of also says to use law of cosines. And so what I'm going to say is x squared equals, and then I'm just going to follow the formula here that a squared equals b squared plus c squared minus 2bc times cosine of big A. And so it's going to be the other two sides squared minus 2 times 17 times 22 times the cosine of 108. All right, so on this one, since we kind of know everything on the right-hand side, we're just going to square root both sides. I'm just going to type it into the calculator just like that, all in one step here. So let me do that. All right, we get the square root of 17 squared plus 22 squared minus 2 times 17 times 22 times cosine of 108. And this will give me, let's see, 31.688, but they want one decimal place here, so I'm going to go 31.7. All right, next up here, they want us to find this missing angle, and they give us all three sides. They say this one's 13, this is 8, and that's 16. So this one we're looking for the angle, so I'm gonna build my law of cosines again. So since I'm looking for angle C, I have to put big C out front. Since I'm looking for angle C out back, and so the other two sides I'm going to add together and square them, and then minus 2 times 8 times 13. Okay, great. So first thing we're going to do here is I'm going to subtract these guys over. So I'm going to say 16 squared minus 8 squared minus 13 squared equals negative. Actually, I can multiply all that together if I want. 2 times 8 times 13 is 208, cosine of big C. So then I'm going to divide that by negative 208 on both sides. And then I just have to get rid of the cosine, so I'm just going to do cosine. I'll do this in a different color here. Cosine inverse of all of that, and that is going to give me my value for C equals. So I'll do cosine inverse of 16 squared minus 8 squared minus 13 squared. Shoot. You know what? I need an extra parentheses here if I'm going to type all that in, since we have the subtraction in the numerator. So I'm going to do double parentheses up there, and then divide that by negative 208. Okay, good. So if I do that, I get 96.34, which it says do one decimal place, so I'll say 96.3. Next up here, it says to solve the triangle, so I will draw it out here. So we have A, B, C. Little a we know is 3, little b is 4, and then C is 52. So it looks like it gives me the side angle side here. So that is going to mean we were going to start with the law of cosines. You can also see I cannot start with the law of sines because I don't have one complete fraction for law of sines. So I'm going to say, let's see, we'll call this little c squared equals 3 squared plus 4 squared minus 2 times 3 times 4 times cosine of 52. And in this case, when we're looking for the side, it's just easy to type it in the calculator in one step. Okay, minus 2 times 3 times 4 times cosine of 52. And so C is 3 point, what do they say, one decimal place here, so I'll say that's 3.2. And now what we can do is go ahead and set up a law of sines to find another angle here. So I will do sine of 52 over that newfound 3.2 equals sine of, it doesn't matter what I find next, I'll go ahead and find big B next, over 4. So we will cross multiply that. So 4 times sine of 52 divided by 3.2. And that's going to equal sine of big B. So then to find big B, I'm going to do the sine inverse of all of that. So I'll type this into the calculator now, but a little quick note here. I can't use 3.2 here because I rounded it too much. So instead of that, I'm going to use my previous answer button on my calculator. Since the last calculation I did was this one up here, I'm just going to reference that answer. that previous answer here. So we're going to go sine inverse of 4 sine 52 divided by, and then I use the answer button on my calculator. It is kind of the second and then negative button. And that's going to tell me that this comes out to 80.3. So a little bit of a challenge there for the rounding issue. The other thing I might say is that if you don't have that answer button, just instead of using 3.2, go ahead and just take this out to like let's say five digits here. And that'll get you a more accurate answer. That'll be more accurate to like the nearest first decimal place there. So careful on that one. Okay, lastly then, for angle A, I don't need to use any more law of sines or law of cosines. I can just do 180 minus 52 minus 80.3 to give me my angle A at 47.7. All right, next up we have to solve the triangle here. It is all sides given. So we are going to go ahead and we start off with law of cosines here because we definitely don't have any complete fraction if all we have are sides. We don't have an angle with its opposite side. So a quick note on this one, if you are doing this, you always want to find the biggest angle first. This will avoid the ambiguous case in law of sines once you get to that step. I did say we're going to start off with law of cosines, but we're eventually going to use law of sines. So if you start off by finding the biggest angle first, you'll avoid that. So to me, it's obvious that the biggest angle is C, since it is opposite the biggest side. And so I'm going to put side C over here, which means we're actually going to be finding angle C on this side. Okay. So we got minus 2 times 12 times 48. Okay, and so I'm going to go ahead and subtract these guys over. And so as I rewrite that, it's going to be 50 squared minus 12 squared minus 48 squared equals negative. And once again, I'll go ahead and multiply these. 2 times 12 times 48 is 1152 times cosine of big C. Divide that by negative 1152. And then we'll do a cosine inverse in the calculator. And again, I need the extra parentheses up here because only when I'm typing it in the calculator, because that's subtraction in a numerator. So I'll do cosine inverse and then an extra parentheses, 50 squared minus 12 squared minus 48 squared. Close one set of parentheses and divide by negative 1152. And so for that, I get angle C at 92.6 if we take it to the nearest decimal. So that's good. All right, so then next up, we're going to do a law of sines to find either of the other angles. It doesn't really matter which one I find next. I'll go ahead and find angle A next. So we're going to say sine of that newly found. Actually, I'm going to use the answer button here, which is referring to angle C, divided by 50 equals sine of, what is this? It'll be big A over 48. Okay, so then we'll go cross multiply that. So I got 48 times sine of my previous answer, which is once again referring to angle C. And then divide that by 50, and that's going to equal sine of big A. So now I'm going to do the sine inverse of both sides. I'll get angle A at the sine inverse of 48 times sine of my previous answer. And once again, if you don't have that answer button, you can just take that angle C out to like 5 digits so that it's more accurate here. Divide that by 50, and that gives me 73.5. So I have this one is 73.5. I have angle C at 92.6. So then if I just subtract those from 180 minus 92.6 minus 73.5, that is going to give me 13.9 for my last angle. So the last angle should always be the easiest. All right, next one here, I'll go ahead and draw my triangle. And so we have angle B, I'll put it there, is 43. Side B is 129. Angle C we don't know, but this one will be 164. And we don't know angle A either. So in this case, I'm actually going to start off with law of sines, and I'm going to be finding the angle first, which means that there may be two triangles possible. It's already kind of implying here with that extra space that we might have an A2, B sub 2, and then a C sub 2. Once again, this happens a lot when you are it's the side angle. As you can kind of see, our information is given side angle like that, wrapping around that way. We don't have to do this if it's side angle side. So if my other known was over here, I wouldn't have to do this, but it's just when we have that side angle, this one's always possible. So I'm gonna go ahead and build this with the givens here right now. And then we'll start off with a law of sines. So we say sine of 43 over 129 equals sine of big C over 164. So I'll cross multiply that. So 164 times sine of 43 divided by 129 equals sine of big C. So I will do a sine inverse on that. So sine inverse of 164 sine 43 divided by 129, and that's going to give me all this 60.1, and so this will be 60.1 right here. And then to find C sub 2, I would do 180 minus that 60.1. And that's what we always do on the ambiguous case. Whenever you find an angle first, using law of sines, you subtract it from 180 to find your second angle here. So this will be 119.9. And so then I can subtract from 180 on the triangle on each of these to find out what angle A is. So A sub 1 is going to equal 180 minus 43 minus 60.1. And that'll give me 76.9 here. And same idea here for A sub 2. It'll be 180 minus 43 minus 119.9. And that'll be 17.1. Oh, but you know what? I already see here that what they wanted was they wanted for A1 to be smaller than A2. So actually you're going to have to flip-flop these pieces of information here. So the way I did it, it's just reverse of that. So just to follow these instructions right there, you're going to have to switch your triangles. But I'm just going to complete each triangle on its own now, and then just know that you need to flip it so that A2 is bigger. Wait, A1 is smaller than A2, or A2 is bigger than A1. So these triangles are going to flip eventually. So lastly, I'm going to find my A values on each triangle. So I'm going to say sine of 43 over 129 is going to equal sine of 17.1 over little a. And so if I cross multiply here, that's going to mean that little a equals 129 times sine of 17.1 all over sine of 43. And so let's do that. 129 sine of 17.1 divided by sine of 43. Okay, so we get 55.6. Shoot. All right, and then I'll also, so wait, what was that? Okay, yeah, 55.6 right here. And then lastly, I'll go ahead and find my side A sub 1. So that'll be on this one. Sine of 43 over 129 equals sine of that 76.9 I have there over little a sub 1. So we'll go ahead and cross multiply those. So a sub 1 will equal 129 sine of 76.9 all over sine of 43. All right, so I'll type all of that in. 129 sine of 76.9 divided by sine of 43. That's going to give me a 184.2. Okay, and then lastly, just remember again, I already said it, that we do need to switch these two just because of these instructions right there. All right, next up here, they are telling us that angle A is 36 and angle C is 84. So they don't tell us which we need to use, law of sines or law of cosines, but we need to find side x here. So I know I can do sine of 36 over x, but I need another complete fraction to do that, and it looks like I don't here, but actually I can find angle B right now by doing 180 minus 84 minus 36. So anytime you have two angles, just remember you really have three. So you can always get that last one, which for me is at 60. So I can set this equal to sine of 60 over 3, and we got 3 sine 36 divided by sine 60. And so that's going to give me a it says 2 decimal places, so 2.04. All right, next up here we want the area of this triangle that has these three sides. So we'll just label them 15, 9, and 12. It doesn't really matter which one's which. So for this one, you could use Heron's formula if you want to look that up. I find that one hard to remember, so I always use the area for triangles of a non-right triangle is 1/2 times AB times sine of big C, which really means just any two sides with any included angle. So I'm going to find one included angle here and just use that to find the area. Doesn't matter which one I find, so I'll go ahead and I'll just find this one right here. So I'll say 15, I'll use law of cosines for that anytime we have all three sides. So 15 squared equals 9 squared plus 12 squared minus 2 times 9 times 12 times cosine of, I'll call it, what will that be? That would be big A. So then I'll say 15 squared minus 9 squared minus 12 squared. If I move those guys over, it's 18 times 12 is negative 216 times cosine of big A. Divide that by negative 216, and then we will take a cosine inverse of all of that, and then I do need those, let me try to draw that better. Cosine inverse of all of that with extra parentheses on the top, and that was 216. Okay, so let's do that. Cosine inverse parentheses 15 squared minus 9 squared minus 12 squared divided by negative 216. And I get there that this is actually a 90-degree angle. Oh, you know what? That's going to make this even easier. Angle A is 90 degrees. Okay. And that's going to make it easier because actually if this is a right triangle, I can actually just use 9 and 12 and say area equals 1/2 base times height. And so in this case, what is that? That's going to be 6 times 9. That'll be 54. If you did use this formula instead, it actually still work. 1/2 times 9 times 12, and then we're saying it's the sine of the angle in between those, which is 90. That's still going to come out to 54 because the sine of 90 degrees is 1, so that does not affect the problem. All right, next up here we have another area problem. It looks like two identical triangles here, so I'm actually just going to find the area of one of those triangles and double them. So I know they're saying this is 2, and then these are 6s. And so what could we do here? We got a couple of options. How would I do this? I think what I would do on this one, and this isn't the only way, you could do what we did on last problem and use law of cosines to find a missing angle. But since this is an isosceles triangle, we're actually allowed to drop an altitude down here, and that actually splits this up into 1 and 1. And then I can use a Pythagorean to see that this will be 6 squared, not 2 squared, 6 squared equals 1 squared plus the height squared. So then that'll be 35 equals h squared, which will make this the square root of 35. And so I can say that the area of this triangle then is 1/2 times 2 times radical 35. Since this is a right angle here, and once again, when this is an isosceles triangle, that altitude, that right angle imaginary line cuts the bottom in half there perfectly, so that allowed me to do this. So the area of this triangle then would actually, since these two cancel out, just be rad 35. But remember though, I had the area of the two triangles because this was just one of them. And so I would say that's 2 radical 35. It's just, you have to double it. So it does want a decimal place here, so I'm just going to do 2 radical 35, and that's going to give me 11.83. All right, next up here, let's see, we have two cars diverging at a 55-degree angle. So we got 55 degrees there. So this is car 1, this is car 2, and let's see, they leave at 2 o'clock, and then how far apart are they at 2:30? So we're trying to find this distance right here. And one of them is going 54 miles an hour, but they're only going 54 miles per hour for half an hour. And so I have to cut that in half here, and so this distance is actually going to be 27. And so same thing with the other one. That's going to be 58 miles per hour times half an hour. That's going to be 29 miles. So you do have to take into account there the time that they've traveled. And so now I'm going to, it looks like I can solve this by using law of cosines since it's a side angle side. So I'm just going to say x squared equals 27 squared plus 29 squared minus 2 times 27 times 29 times cosine of 55. And then we can just square root both of those and type it in to our calculator. And if I do that, I get x at 25.92 if we go to the nearest decimal place. All right, next up here, it's actually the same idea here as the last question, but they're doing it in terms of like bearings. But they did draw the picture for you. So north 50 degrees east means you start north and then you go 50 degrees east, which you can see they did right there. And then south 70 degrees east means you start south and go 70 degrees east from there. Now, what's really important to me here is that I know that what this angle is in the middle. And since it's sharing a straight line with that 50 and that 70, I would say that this is 60, so it could all add up to 180. And so when I draw my triangle, I'll go ahead and do that over here. I know that this is a 60-degree angle. They eventually want to know the distance right here, which is x. And in this one, they did the miles a lot easier here because we're only going for 1 hour. So if we go 24 miles an hour for 1 hour, obviously that's going to be 24, and this one's going to be 25. I mean, if you want to show your work here and say 24 miles per hour times 1 hour, then feel free. But I mean, if you're going for 1 hour, that's just your distance. So from there, you're just going to set up your law of cosines just like we did on the last problem. So it's going to be x squared equals 24 squared plus 25 squared minus 2 times 24 times 25 times the cosine of 60. And then we square root both sides, type it in the calculator, and that's it. All right, next up here, it looks like they're giving us all these cable lengths. So these tugboats, it looks like the tugboats are going this way, and they're pulling the barge, and they are 100 feet apart. And I should not have done that in blue. Here, let's do that in green. Oh, can't see that either. All right, let's try red. All right, cool, 100. And then for me, this will be 218 here, and this will be 225. And they want to know the angle formed between the two cables. So this is the angle between the two cables, because that dashed line is it's not one of the cables. So looks like I'm gonna have to use law of cosines here. So I'm gonna say since I want theta over here, that's not squared. Since I want theta, it's going to be inside of a cosine, which means I need this side opposite theta over here. And so the other two, in whatever order you like, are going to be going here and here, and then minus 2 times 225 times 218. Okay, so looking for the angle here, so we're going to have to subtract these guys over. And that'll equal, and I'll go ahead and multiply these numbers together. -9, 8/100 cosine of theta. So we'll divide that over. And then we'll do a cosine inverse. And I do need those extra parentheses. All right, so let's just type that in the calculator, extra parentheses after the inverse. And then we got 100 squared minus 225 squared minus 218 squared. We'll close one of the parentheses, divide it by -9, 8/100, and then close the second set of parentheses. And what did I get? I got 26.03. How do they want us to round to the nearest degree? So that's just going to be 26 degrees. Oh, they already have the degree sign there. All right, next up here, we got a triangle going on. And let's see, they tell us that A is 19, this one's 20, and that one's 40. Call that big C or gamma if you like. And so I always say to find the biggest angle first when you're doing these. And so I'm going to find angle C, which means I have to put side C over here. Minus 19 times 20. Oh, I forgot the 2, but I'll just multiply that right there. And then cosine of big C. Okay, so now we'll move stuff around. So I got 40 squared minus 19 squared minus 20 squared equals, let's see, 40 times 19 is just -760 cosine of big C. And then we'll divide by -760. All right, and then we'll take a cosine inverse of all of that with, of course, our extra parentheses right here for calculator use. And so I have big C equals, and actually when I type all that in, I get domain error. And this actually means that this triangle is not possible. And I actually could have known this from the start, because on any triangle, the smaller two sides have to be, if you add them up, greater than the largest side. So A plus B has to be greater than C. And once again, that's any triangle, so don't get this confused with Pythagorean theorem, because we're not squaring them here. We are just saying that the sum of the two smaller sides has to beat the bigger side. If you kind of visualize this, if I made this 40 right here, I could make this as like a super small angle, and that be 20, and this be 19. And obviously that's smaller than 40, so those two there's no angle that I can make those two meet in. So this one's going to be a no solution. All right, next up here we got a baseball diamond, which is actually not a diamond, it's actually a square, because all of these are right angles here. And it's 90 feet on kind of all of these. And the kind of weird thing they're asking us about here is the pitcher's mound. Which they say is 60.5 feet away from the home plate. And so they want the distance from the pitcher's mound to all the bases. So I think the really easy one here is the pitcher's mound to second base, because, oh, actually that's not as easy as I thought. Well, I mean, what we'd have to do there is we'd have to Pythagorean to find like this whole distance. So I'll do 90 squared plus 90 squared equals C squared. So that is 16,200 equals C squared. And then square root that. And how they want me to round this? The nearest one decimal place. So this is 127.3. And then I'll subtract that from the 60.5. and then we have 66.8. Okay, so that's good for that one. Next up, we're going to need the distance from the pitcher's mound to first base or third base. These are actually going to be the same, so I'm just going to find this once. And so we're going to have to create like another kind of triangle right here. Okay, and so what do we have on this triangle? Well, I know that this got split in half here, 45, 45. So if I draw this triangle out here, the information I have is this is 45, this is 60.5, and this is 90. Now this is not a right angle. I kind of drew that as a right angle. I wish I wouldn't, but this is not a right angle right here. But I do kind of want to find that angle, I think. Oh, no, I don't. I don't need to find that. Never mind. I just need to find this, and I have a side angle side, so I can use law of sines. So I'm going to say x squared equals 60.5 squared plus 90 squared minus 2 times 60.5 times 90 times the cosine of 45. So I would just square root that and type that whole thing in the calculator there since it's all on the right side, and that's going to give you your answer for these two right here. I'll let you guys do that on the calculator. All right, next up here, they want us to approximate the area of ABC. So I'll go ahead and draw the triangle first. So we have angle A is 80, and then let's see, this is 30, and this is 20. And we can always use our area equals 1/2 AB sine C here. And the key with this one, even if it's not the same letters, which this one is not, this angle right here needs to be in between those two sides right there on the triangle, which you can see that this one really is. And so I can just go ahead with this formula, 1/2 times 20 times 30 times sine of 80. So if I just type that in the calculator, 20, 30, sine of 80, and that's going to give me, if you round it to the nearest whole number, it'll be 295 for me. All right, next one here, let's do this again. So we have this one, B. Let's see, angle B is 56, angle A is 36, and then side B is 4.48. So I'm thinking about my 1/2 AB sine C here, but on this one, remember that we need that angle to be in between these two sides, and that is not the case right here. So what I can do then is I can just find another side here. I'm going to go ahead and find side C. And I'll do that using law of sines. So I'm going to subtract 180 from the other two angles to find that missing angle, which would be 88. And then I'll do sine of 88 over little c equals sine of 56 over 4.48. Cross multiply that. 4.48 times sine of 88 equals c times sine of 56. So we'll divide that by sine of 56. And get our value for c, so that'll be 4.48 times sine of 88, and then divided by sine of 56, and that'll be about 5.4. Okay, and now I have two sides with the included angle right here, and so I'm going to use those. Area equals 1/2 times 5.4 times 4.48 times sine of 36. 4.48 times sine of 36, and that's going to give me a I forgot to multiply that by 1/2. There you go. Okay, so that's going to be, my area is 7.11. It says it wants 2 decimal places. All right, next up here, we got 2 red and 5 white balls. We're taking 2 balls out. So the probability that both of them are red, that would be 2 out of 7 for the first ball, and then since I'm pulling them both out at a time, I do need to kind of assume here that we got it on the first time, we didn't put it back, and so that will reduce the numerator denominator by 1. And so that's going to be, actually I can reduce that, and so it'll be 1 over 21. They did want a decimal for that, so for me, that is going to be 0.048. And same idea for white, so it's going to be 5 out of 7 on the first one, and then if I get that first one, it'll be 4 out of 6. So that is going to reduce to 2 over 3, so this will be 10 over 21, and that's going to be 0.476. All right, next up here, one more probability. So we want the probability that the spinner stops on red. So red, let's see, how many do we have here? Well, there's 16 total. And how many reds are there? There's 12. So I would just reduce that to 3/4. An odd number, well, an odd number, I think half of those are odd, right? So it's 8 out of 16 or 1/2. And then a red or an odd number. Well, for red or odd number, a couple ways we can do this, but we always learn with or is that it means addition. So I can actually add here my 12/16 plus my 8/16. However, I need to subtract out any overlap here. So those are the ones that are red and odd. So let me count those up for my overlap here. So that's a red odd one, red odd, red odd, red odd, red odd, red odd, red odd, red odd. So how many do I have there? So I have 8/16. So that's actually just going to end up at 12/16, which is 3/4.